Okay, good afternoon. It's time to start. So as we discussed last time, we are going to be rescheduling our first exam. Originally was scheduled for Wednesday this week, but since some of you have another exam that day, I was requested to consider. So I decided to reschedule to Monday, October 21st, and it will be during the class period. And today we're going to do a review, basically go over the topics that we cover for this first part of the semester. And those are going to be the topics that are going to be included for this first exam. The plan for today, the review, I believe, I mean, if you don't have a lot of questions, shouldn't take much time. But I also graded the project proposals. So my plan for today, after we go through the review, I also brought some slides to give you an idea of how the progress report is going to look like. So we'll talk about that a little bit today. The progress report will be due on November 4, and for that, you had to do a presentation. So what we are going to discuss today in terms of the progress report is the format of the presentation and the work that you had to perform in terms of having certain things ready for that progress report. And then after we cover that part of the project, then I will go and meet with each one of the teams individually. I will provide feedback on your proposal, and I'll show you the score and where are the areas of improvement as you move forward with your project for the rest of the semester. So that's basically the plan for today. So first the review. Second, we're going to talk about the progress report. And I already posted the assignment for the project November the 4th, if I'm not wrong. That's a Monday. So you should be ready to do a presentation by that day. We're going to talk about the presentation and the work that you need to do. And then I'll meet with you guys individually to provide feedback on the project proposal. Any questions? Yes, sir.
What's that informed conflict?
Yes, so that's on the schedule. I decided not to go to that conference this year. So that was last minute decision. So I'll be here during that time. So don't worry about that. We'll be having class normally. No, it will be fine. Any other question? Yeah. Good. So let's talk about the review. The exam again on Monday, October 21st. So today we do the review. Wednesday, we're going to start with new material that is not going to be part of the exam. Okay. And then on Monday, we'll have the exam. So let's start with the format. There's two sections in the exam. The first section are 3 true or false multiple choice questions. So those are based on all the topics, concepts that we have discussed. I'll show you those topics one more time today, and I'm gonna highlight those that are more important so you can focus on those. And the questions will come from there. So those 10 multiple choice true or false questions are 2 points per question. So that will be a total of 20 points of your exam. And then we have 3 to 4 problems on the second section. These are 80 points. So things that you should be able to do connected to those diagrams that we've been preparing during the semester. So make sure that you know how to develop a causal loop model, how to build an n-squared chart, which you did for your project proposal. So in the exam, I'll present you with a case, specific case, and you're going to be building a causal loop model n-squared chart based on that specific case. And then remember those other diagrams. I Let me try to see either we cover several. Excuse me.
Context diagram.
Yeah, the context diagram could be another question. We have talked about many different things, but causal law models for sure, n-square chart, context diagrams, those you should be able to work to build those. Again, I'll be presenting you with different scenarios, and then based on those, you should be able to present me with the diagram based on that scenario. And then questions could be also based on topics. We have discussed the systems engineering method, so you should be aware of what the systems engineering method is. What are the steps? What do you do in those 4 steps? How does that connect to the system lifecycle model? We also talk about the system materialization process. We also talk about the hierarchy of a system, the system lifecycle model. So those are things that you should know. Okay. Yes, sir.
System engineering.
Method, system engineering method. So those are very important topics that I can ask you questions. I can ask you to list the 4 steps of the systems engineering method and explain those. I can ask you what are the steps or the stages and the phases of the system lifecycle model. I can ask you to, let's say, talk about the first stage of the system lifecycle model and connect that to the hierarchy of the systems engineering, or the hierarchy of the system in terms of materialization. So we have a table that shows that in the lecture notes. So again, I'm not expecting you to memorize word by word what is in the slides, but you should know at least conceptually what is needed in each one of those steps. So again, I'm not expecting you to give me a complete sentence specifically like we have stated in class, but if you go work to explain in your own words what this is, you should be able to do that. Okay, so that's more or less the format of the exam. And then I'll show you the lectures that we have covered. So lecture 1, we have Introduction to Systems Engineering. So this is a lecture that is more in terms of showing the students what to expect in a class that is about systems engineering. So there's not a lot of concepts in this lecture. It's more about definition of what systems engineering is, some examples, and so on. So next, yes, sir. So next we have the lecture 2, and as you can see, I'm highlighting certain things here. So structure of complex systems. So make sure that you understand what the hierarchy of complex systems is. So we talk about that hierarchy in class. We also discuss the system building blocks. So out of the hierarchy, what is that hierarchy level that we need to be able to explain to a specialist, right? What's the level that we as systems engineer we should be informed about? We talk about the component level, right? So why is that important? Why do we need to go up to that level? Those are things that we discuss in class. The system environment, system boundaries, type of interactions, interfaces, and the complexity in modern systems. Moving forward, lecture 3, we have the system development process. So the system life cycle, make sure that you understand what that is. The 3 stages: concept development, engineering development, and post-development. In each one of those, we have separate steps. For concept development, we have the needs analysis and so on. So make sure that you understand what's inside each one of those. The systems engineering method. So as I mentioned, 4 steps. So make sure that you understand what what the 4 steps are and what do you do in each one of those steps, and then testing throughout the system development. Questions? Problem definition. So here we spend more time specifically because I knew that you were going to do the proposal. So we spent some time talking about how to define a problem, who is involved, how do you interact with each one of these different stakeholders. Like if you're talking to management, if you're talking to the operators, what are the different tools that you use when you are trying to gather information from these different stakeholders? Functional and requirement analysis. What is the output of the problem definition phase? And there's an example at the end of this lecture that I ask you to read. At the end, we have like a hierarchy of functions, right? Based on those needs that were discussed based on the stakeholders. So we know what are the functions that the system must do in order to address those requirements. And we build this functional hierarchy based on that. Then we transition to the systems engineering management. So this was more into discussing the documentation of your system. So managing the system development, how do you go from getting a announcement that there's a need and you need to submit a proposal in order to address that need? What are the documents that are typically prepared in order to submit that proposal? And then the systems engineering documents for our course project. So you don't have to memorize this. There's no need for you to know this by memory. This was more in terms of what you should expect in terms of your report for the end of the semester. And then we go back here to needs analysis. So highlighting their operations analysis and functional analysis. So how are those connected? The feasibility definition of your system, needs validation. So these are things that we covered last week. And the system operational requirements. We also discussed the system thinking and system thinking tools. So here's where we talk about the cost loop model and the N-squared chart. But there are other things here that I discussed. What are the fundamental system construct? What are the fundamental system principles? Make sure that you know those. And the system thinking tools are those that I just mentioned, causal loop model and then square charts. And then finally, this is our last lecture for the first part of the semester. Systems engineering and design of large-scale systems. So here we go through the development of the requirements for your system, starting with the input-output requirements. So make sure that you know also those 6 different type of requirements. Those are important. So what are those 6 different type of requirements? And which ones are needed for you to have a functional system design, a buildable system design, and an implementable system design. You should know what is needed in terms of requirement definitions for you to move from one to the other. And what is the difference between functional, buildable, and implementable system design. And that's it. That's the material for the first exam. This is the type of class that is not, it's maybe a little different from the other coursework that you're used to take, in which you have a lot of math intensive type of problems. Here's more about presenting a solution to a problem that is presented to you, and then you're using some of the tools to address those or to explain your solution for that problem. Questions? Yes.
The textbook, there are 4 textbooks in your syllabus, and which one should I?
So the textbook, so for each one of the lectures, there's a reference listed.
Yeah.
my advice is to focus on the one that is for the textbook for the course. Because that most of the information is coming from there. In the case in which I'm choosing other references is because I'm taking pieces from other books. There's not necessarily a chapter that I can tell you, go to that chapter and study that chapter. So yeah, for the most part, is the book that was reference for the class. The book that is actually in the modules you should have access online to that book. Yes, Korsyakov books. Yeah. Any other question?
Another question for, into an M square, I was confused that those are same or different, M square diagram or N2 diagram.
N square should be N square. And two, maybe I wrote that because I was not able to put the square. So it's N square.
Just one N square diagram.
N
not
square,
N2 diagram.
yes, if you see N2 is because I was not able to do the exponent. Yes.
Explain the difference between the N2 and casual. They provide the same information.
That's a very good question. So both of them, so the question is, what is the difference between the causal model and the N square chart? So both of them are tools that are helping you to understand your problem, but they're doing it from different perspectives. The causal loop model, you're trying to list let's put it, variables that have some type of impact on your problem, and then you're trying to map how those variables are interacting with each other, right? So if this variable having a negative or reinforcement, or I'll say negative impact or positive impact into this other variable, right? So at the end, once you build this causal loop model, what you have is a visual representation of the interactions from all these variables that are part of your problem. The diagram itself is helpful in the sense that you can start identifying areas that you can address. And those areas can help you solve or maybe improve some of the areas for your problem. So those areas could be part of your system, or those ideas or interventions that you're proposing to help can be part of your system. So that's the idea of the causal loop model. The N square is more addressing the structure of your system. So now you're also looking at interactions, but you are trying to identify entities now, right? Those are the ones that are in the diagonal. So in a sense, who are the people, or who are the, I say entities, could be machines, could be people, whatever is interacting with your problem. So you try to identify those, and then you are trying to also understand how are they interacting with each other. So for example, I don't know, if you're thinking about a car, what are the different entities that are part of the car? What are the entities that are interacting with the car? And then you're trying to connect, oh, this part is somehow sending information to this other part, and that is creating this reaction for those two, right?
So it doesn't show like the positive or negative impact.
No, like the causal loop model. But the N square chart is helpful in a way, because again, it's more focusing on the structure. And then you can start, the good thing or the positive thing about the N square chart is that you can start looking at potential groups, identify, okay, these three entities are interacting a lot. These other three entities are interacting a lot. So that can give you some idea in terms of how your system can be split into subsystems. And that's one of the things that I'm going to discuss with you in terms of the feedback. So when you build that N square chart for your project proposal, I wanted to see if you can identify based on those interactions subsystems for your project. But that's the answer. I don't know if that helps. That helps. Good. So any other question?
Professor,
Yes.
for n squared are, external inflows and outflows. Can you explain this?
Yeah, so the n squared chart you can build it only for the system. Let's say you have your boundary. If you're looking at the car, it's just the car and the components inside the car. But you can also add an additional layer and think about what other systems are interacting with the car. Let's say gas stations, right? Or
So external factor that.
yes, exactly. So external, which are important for your system, right? But you're trying to also illustrate them within your n
Like
squared chart.
traffic signal.
Yes. So that's the internal, external. So external basically outside the boundary of your system, but still have some interactions with your system.
Okay.
Yes, yes. Any other question? So again, we have Wednesday. So if you go study today, we can talk on Wednesday if you have questions before we get into the news material. And on Thursday, I have office hours, so take advantage of the time that you have. I know you have other exams, but if you can take an hour, go over and find out if you have questions, then we can talk before the exam. Good. Okay, so to prepare for the exam, read chapters 1 through 5 from your textbook. That could help. The lecture slides should be very complete in terms of the material. If you study the lecture slides very well, the labs and the assignments, you should be able to do very well in the exam. The exam is closed book and notes. If you're doing your diagrams, make sure that you use your time wisely, right? If you're doing an n-squared chart, don't take an hour because you also have to work on the other problems. So put something, try to fill out those boxes as much as you can, and then move to the next problem. If you have more time, then you can go back to the problem. But the important thing is that you can cover all the pieces that are part of the exam. In this case, we don't have formulas, so no need to show formulas. But remember, for causal loop models, you need to specify your notation in order for me to understand what you're doing. Notation in the sense of two different arrows, which one is reinforcement, which one is the opposite. Anything else? Yeah. Okay, so that's the review. Now, questions? So as I said, I posted a new assignment for your project. And the progress report is due on November 4. So we have a little bit more than 2 weeks. Just go close to Canvas. So this is the assignment that I just posted. There's a link to the semester project document that was shared with you already. So the midterm report is a presentation you're gonna do. Each team will be presenting for 8 to 10 minutes. So you will decide if you are a team, only one person will present, or if all of you are presenting make sure that you're using your time wisely. And it's up to the team to decide who will be the speaker. Progress report presentation must discuss these three areas: problem situation or problem definition, customer requirements, and some derived technology requirements. So as an example, I have here a progress report from an old project. In this project, the students were proposing a system that will create an ecological system outside the Earth, right? Like they're proposing for Mars right now. Like they're gonna take all this and then gonna build an environment for humans to live outside the Earth. So that's the project. And for the progress report, there were 4 areas here. Problem situation, customer requirements, system description in terms of input-output requirements, and then some derived requirements. So the idea here is that you get into the process of starting to define your requirements, at least from the input-output, which is the first set of requirements that we discussed last week for the functional system design, right? So here. Okay, so from that point of view, we start by defining the problem. So you can do this from different ways. One way would be to present some of the facts, like in bullet points. These are the things that are defining your problem. Or you can create some type of animation like this one. So there are some hazardous situations like global warming, nuclear wars, ozone depletion. So in this case, we're trying to present what are the possible situations that can take the Earth or put the Earth at risk for the need of this system. And then based on that, they started creating some requirements for the system. At this point, these are operational requirements. They are high level, right? There's no numbers here. These are the things that the system must do. So next week, we're gonna start talking about how to write requirements, or probably on Wednesday, we're gonna talk about how to write requirements. There's a formula for writing requirements. There's certain words that we're gonna be using. Like for example, shall, you see shall there is almost every requirements that means something. Must is another word. So here, 7 requirements, high level. And then in here, they at the high level also started looking at the different subsystems for your system. So there's a system for energy, system for humans, waste treatment, water cleaning and availability, and then flora and fauna. They also stated a need for regulating the conditions inside the system. And then based on that, they started showing how the system could be connected. So input output for the overall system, and then inputs or output from the energy center that are becoming inputs to the other systems, right? Food, clean water, contaminated water can go back to here. And then that goes back to treatment. So yeah, that again, based on their understanding of how the system must operate, and then They look into the different subsystems. This is the overall system. Yes, sir.
Is that the CMM that they gave me?
This one right here is just input output. There's not causal loop model. This is just a way to represent the inputs and outputs for your system. This is called a push egg. I think we mentioned it in one of the lectures. Is a circular diagram that you can build like little cells and you can show the hierarchy of your system. So in this way, in this case, we have one circle, two levels, right? One big circle, and then the second level are the small ones. And then what they are doing is showing the connections. And instead of showing all of them at the same time, will be very clear. Yeah, they're just animating them for illustration purposes.
Oh,
Okay.
thank you.
And then they're showing the input output for, so this is at the top level. This is for the overall system. What are the inputs? What are the outputs? And then they're also looking at what are the things that they will use to create the structure of the overall system. So they were looking more into a dome type of structure for this system. So there are different materials that we're considering for the shape. And then for the energy, what are potential technology that they can use? So they were looking at solar energy. For water, what are potential technology that they can use? There's reverse osmosis, ultraviolet sterilization. For waste treatment, there's two different technologies that they were able to identify. And for the flora and fauna, they stated what technology they can use to create some or to make the food available for the humans and for the other animals. And then finally, the regulator system, they were looking at, and that's how do you regulate the conditions? So there's some systems here that can be used. And for the human, what are the things that are needed for a human? Medical facility, machine and wood shop, communications, living quarters, recreational areas. And then the last thing they did, which I think they pushed the limit a little bit here, was to try to come up with some performance requirements in terms of how are they going to make sure that they have enough oxygen for people inside the dome. So they were trying to make some computations here in terms of how much air will be needed and how much CO2 will be generated per human. And if they have a system enough to clean the air for continuously for the oxygen to be available. And then how can they use that also for photosynthesis and plants and food. And that was it. So that's an example. Again, you can build it around your project. But that's I really like this particular presentation. This is like one of the best ones, so that's why I'm showing it here. Doesn't mean that every team had shown something like this. It's just like I like to set the bar high, so in case you want to replicate some of the work that was done by this team. Questions?
Professor, in the
Yes.
project outline, there are total 8 docs.
Yes.
Topics. So in the progress report, should we touch all the docs or
No.
partial?
No. So basically, what I'm intending you to do is to get started. Like basically, kind of force you to get started. And once you get rolling, I think you can continue working on the documents. So that's the idea of the progress report. I put you in front of people, so you're like, okay, I need to start working. And then during November, I'll be maybe creating some sessions that are gonna be for the project itself, in which you're gonna be working and I'm gonna be providing feedback like we did for the proposal. So that's a good question. For the documents, yeah, at this point, I'm not asking for any of the documents. I just want you to start thinking about at least the concept, how it's gonna look like, what are the subsystems, what are the input outputs that are gonna be needed for your system. Okay, yes, sir.
Can you have maybe another example?
Yes, I can look for another presentation. Yeah, I can do that too. Yeah, yes, yes. I have a lot of them, so I can easily put some of the other ones. Yes.
Yes, sir. That's good.
Any other question? Good. So, okay, so the third thing that I have planned for today is to meet with you guys individually to provide feedback. So, so that's what I'm gonna be doing now. And that will be all for today. So let's